Greetings, science fans! Our planet is facing a big challenge, climate change. For centuries, we've relied on fossil fuels, coal, oil, and natural gas to power our lives. Burning these fuels releases carbon dioxide, trapping heat and warming the planet. The effects are real. Extreme weather, melting ice caps, rising sea levels. We need a new clean way to power our world. Solar and wind are great, but we also need a fuel we can store and use anytime, anywhere. The world is searching for an energy hero. Something reliable, transportable, and clean. Enter hydrogen, the most common element in the universe. It's simple, powerful, and when used for energy, its only byproduct is water. Imagine powering our lives without polluting the air or heating the planet. Scientists and engineers everywhere are racing to make this a reality. The transition to clean energy is a monumental shift, but it's possible. We need big ideas and global teamwork. The good news? Hydrogen could be the answer. It's time to rethink how we power our world. The search for a clean, sustainable fuel is on. Hydrogen might just be the hero we need. But how do we make it work for everyone? Let's dive into the science behind hydrogen and see how it could change our future. Hydrogen is everywhere. It's in water, food, even in us. As an energy carrier, hydrogen can be stored and used in fuel cells to generate electricity. The only emission? Water vapor. Imagine cities with cleaner air and quieter streets, all powered by hydrogen. Hydrogen can be produced using renewable energy, making it a truly green fuel. But there's a catch. Hydrogen doesn't exist freely on Earth. It's usually bonded with other elements. To get pure hydrogen, we need to split water molecules apart. The best way to do this is electrolysis, running electricity through water to separate hydrogen and oxygen. If we use renewable electricity, the whole process is clean from start to finish. This is called green hydrogen, the gold standard for clean fuel. The challenge? Making water splitting efficient and affordable. That's where catalysts come in. Let's see why they matter. Catalysts speed up chemical reactions like splitting water without being used up. The best catalysts for water splitting have been rare, expensive metals like platinum. Using these on a global scale is too costly. The mission? Find a catalyst that's cheap, abundant, and just as effective. Scientists worldwide are searching for the perfect material, one that's efficient, stable, and durable. It's a tough challenge, but the payoff would be huge, affordable, clean hydrogen for everyone. The right catalyst could unlock a green energy revolution. So, has anyone cracked the code? Let's find out. Exciting news! Scientists in Pakistan have made a major breakthrough. At Lahore University of Management Sciences, they developed a new catalyst from manganese and copper, both cheap and abundant. They created a manganese-based metal organic framework combined with copper oxide nanoparticles. This structure offers a huge surface area and excellent electrical conductivity. The result? A catalyst that's efficient, fast, and durable. It works with a low overpotential, meaning less energy is needed to split water. Its performance rivals expensive precious metal catalysts. The team tested it for over 50 hours and it stayed strong. High efficiency, speed, and durability, all with affordable materials. This discovery could make green hydrogen accessible worldwide. It's a game changer for clean energy. Science like this can transform our future. Let's see what it means for the world. This breakthrough is a huge step toward making green hydrogen affordable for everyone. By replacing costly metals with manganese and copper, clean energy becomes accessible to more countries. It's a win for energy independence and a healthier planet. Science solves real-world problems, and this is proof. The journey isn't over. Researchers will keep improving these catalysts. Progress happens one discovery at a time with global collaboration. From a lab in Lahore to the world, this story shows what's possible. The future can be cleaner, greener, and powered by science. Thanks for watching. Let's keep working together for a better world. Hey everyone, welcome back to For Science Salah Lotfy channel. Today I've got an awesome story about how science is literally changing the future of clean energy, and it all starts with a super cool material called Mn-MOF/CuO. So what's the big deal? Well, the world's looking for greener ways to make hydrogen. That's a clean fuel with zero carbon emissions. But making hydrogen efficiently isn't easy. It takes a process called water electrolysis, and that needs great catalysts. Now, platinum or ruthenium usually do the job, but they're expensive and rare. That's where this new research comes in. A team of scientists from Pakistan, Saudi Arabia, Kuwait, Tunisia, and the USA teamed up and created a nanocomposite. That's just a fancy way of saying they mixed two things at a tiny, tiny scale. The two ingredients? Manganese-based metal organic frameworks, or Mn-MOFs, and copper oxide nanoparticles. Here's why that's cool. The MOF brings a huge surface area, think loads of room for reactions, and the copper oxide helps electrons zip around easily. Put them together, and you get a hybrid material that's not just efficient, but also stable and cost-effective. They built this nanocomposite using a hydrothermal method, basically a hot water bath under pressure, and made the copper oxide with a simple co-precipitation technique. The result? In 1 molar potassium hydroxide, this material needed just 247 millivolts of overpotential at a current density of 10 milliamps per square centimeter. That's science speak for it's super efficient. Even better, it holds up over 5,000 cycles and works for at least 50 hours straight. So it's tough too. With a Tafel slope of 48 millivolts per decade, the reaction kinetics are fast, which means less wasted energy. And the best part? The materials are cheap and abundant, no rare metals needed. That means this tech could really scale up for industrial hydrogen production. Imagine a world where hydrogen fuel is made cleanly, cheaply, and at massive scale. But it's not just about the science. This paper, published in the journal Fuel, is a real example of how international collaboration can spark innovation that matters for the planet. When researchers from 5 different countries come together, big things can happen. So, why should you care? Because breakthroughs like this don't just live in the lab, they could power the future, your future, with cleaner air and a healthier Earth. If you're a science student, an engineer, or someone who just loves seeing innovation in action, keep your eyes on research like this. It's proof that science doesn't have borders, and real progress happens when creative minds around the world join forces. Thanks for tuning in. If you like this deep dive, hit that like button, subscribe for more, and let's keep exploring the science shaping tomorrow. Hey everyone, welcome to For Science Salah Lotfy channel, the place where I dive into the most exciting discoveries from across the globe. Today, I'm bringing you something fresh, innovative, and super relevant, especially if you care about clean energy and the future of our planet. So, here's the deal. A group of researchers from Pakistan, Saudi Arabia, Kuwait, Tunisia, and the United States have teamed up for a project that could make a real difference in how we generate clean energy. Their paper is titled, Development of Mn-MOF/CuO Composites as Platform for Efficient Electrocatalytic OER. Yeah, that's a mouthful, but stick with me. It's actually really cool. Let me quickly shout out these minds behind the magic. Dr. Bushra Shabbir, Dr. Nidal Drissi, Dr. Karam Jabour, Dr. Abdelaziz Gassoumi, Dr. F.F. Al-Harbi, Dr. Sumaira Manzoor, Dr. Mohammed Fahim Ashik, Dr. Ha Al-Burai, Assistant Professor, Dr. Mohammed Fahad Ehsan, and Professor Dr. Mohammed Naeem Ashik. That's a serious lineup, right? These researchers span continents from Pakistan to Saudi Arabia, Kuwait, Tunisia, and all the way to Boston in the USA. It's a true international dream team showing how science unites us for one goal, a cleaner, better future. Alright, back to the science. What's this research about? In simple terms, the team developed a clever new material, a composite combining manganese-based metal organic frameworks with copper oxide. This combo acts as a platform for something called electrocatalytic OER. Now, OER stands for oxygen evolution reaction, which is a crucial part of splitting water to get clean hydrogen fuel. Why does this matter? Because hydrogen is one of the cleanest energy sources out there. If we can make hydrogen production more efficient, we could cut down on fossil fuels and seriously help the planet. Here's what's awesome. This new composite material is not just effective, but it's also stable and affordable. The researchers showed that it works better than many existing materials, making the process faster and requiring less energy. That's huge. It means renewable hydrogen might actually become practical on a large scale. And if you're curious about the journey of this paper, it was received in October 2022, revised in January 2023, accepted just a few days later, and published online in February 2023. It's hot off the press and already making waves in the scientific world. So, what's the big takeaway? Science isn't done in isolation, it's a global effort, and breakthroughs like this are only possible when bright minds from different backgrounds come together. To all the university students out there, your collaboration, your curiosity, and your passion are what will shape our world. Stay inspired, keep questioning, and who knows, maybe your research will be the next big breakthrough. Thanks for watching, and I'll catch you next time on For Science Salah Lotfy channel. Hey, welcome back to the channel. Today I'm diving into a discovery that could seriously shake up how we power the planet. Picture this, a world where our cars, factories, even the electricity in your home, runs on hydrogen made from water, not oil or coal. That's not science fiction anymore. Let me break it down. Here's the deal. We're running out of fossil fuels and pollution. Yeah, it's not getting any better. So, scientists have been on a mission to find energy sources that are clean, sustainable, and actually doable in real life. Enter hydrogen. It's packed with energy, way more pound for pound than gasoline, and when you burn it in a fuel cell, the only thing you get is water vapor and some heat. No greenhouse gases, no smog. Sounds perfect, right? But producing it cleanly? That's the catch. The best way to make clean hydrogen is by splitting water into hydrogen and oxygen using electricity, a process called water electrolysis. But the problem is, the stuff we use to speed up this reaction, the electrocatalysts, are either super expensive, think platinum and ruthenium, or they just don't last long. If you want hydrogen that's actually affordable, you need something better. And that's what this new research is all about. A team of scientists developed a new material, a nanocomposite made from manganese metal organic frameworks, or Mn-MOF, combined with copper oxide. Sounds fancy, but here's what matters. Both manganese and copper are cheap and easy to find. They created this material using a straightforward hydrothermal method. No complicated steps, no rare elements. When they tested it in a solution of potassium hydroxide, the results were wild. The new composite needed just 247 millivolts to hit a power density of 10 milliamps per square centimeter. That's a low overpotential, which means it's highly efficient. The Tafel slope, which shows how fast the reaction happens, was only 48 millivolts per decade. Translation: the reaction is quick. And get this, the material stayed stable for over 50 hours with almost zero loss in performance. So why should you care? Because this isn't just a cool lab trick. This composite is practical. It uses metals we've got plenty of, it's easy to make, and it actually works. Plus, it opens the door for metal organic frameworks, these flexible, tunable structures, to play a huge role in next-gen catalysts. We're talking about real potential for scalable, affordable, and truly green hydrogen. Bottom line? Sometimes the game changers aren't big machines or giant reactors, it's tiny materials like these nanocomposites. They might just be the key to powering our future. If you found this as fascinating as I did, hit like, share it with your science-loving friends, and don't forget to subscribe for more deep dives into the science shaping our world. Thanks for watching. Welcome. Today, we're diving into the world of clean energy, a topic crucial for our planet's future. We use energy everywhere, but most of it comes from fossil fuels that pollute our air and change our climate. Scientists are searching for cleaner solutions, and hydrogen gas is one of the most promising. When used as fuel, hydrogen's only byproduct is water, clean and simple. The challenge? Producing hydrogen efficiently, often by splitting water molecules in a process called electrolysis. To make this process work, we need a catalyst, a substance that speeds up the reaction without being used up. The right catalyst makes hydrogen production practical and affordable. Our story follows scientists building a new catalyst to improve the slowest step, the oxygen evolution reaction, or OER. If we can make OER faster, clean hydrogen becomes much more accessible. These scientists use chemistry and engineering to create a powerful new tool for clean energy. Along the way, we'll meet metal organic frameworks and nanoparticles, tiny structures with big abilities. Ready to see how science is building a better future, one molecule at a time? Let's get started. Every great invention starts with the right ingredients, and catalysts are no exception. The scientists chose copper Da2 nitrate trihydrate to make copper oxide nanoparticles, the main ingredient for one half of the catalyst. Sodium hydroxide helped control the reaction, ensuring the copper oxide formed correctly. Manganese 2 chloride tetrahydrate provided manganese, a key element for the other half of the catalyst. To build a strong structure, they used 2-amino-terephthalic acid as a linker, creating a sturdy, porous framework around the manganese. The solvent, DMF, dissolved everything for perfect mixing. Deionized water and ethanol kept everything pure and clean. Why these chemicals? Copper and manganese are the active metals for splitting water. The organic linker forms a metal-organic framework, or MOF, a microscopic sponge with a huge surface area. More surface area means more places for the reaction to happen, making the catalyst efficient. Every ingredient has a purpose, working together to build something remarkable. That's the recipe for innovation. With ingredients ready, it was time to create the building blocks. First, they made copper oxide nanoparticles by reacting copper 2 nitrate with sodium hydroxide, then heating the mixture to form tiny CuO particles. Careful washing and drying ensured purity. Next, they built the manganese-based metal organic framework, or Mn-MOF. Manganese chloride and the organic linker dissolved in DMF, forming a solution of building blocks. Using solvothermal synthesis, they heated the mixture in a sealed container, encouraging the pieces to self-assemble into a porous, crystalline MOF. After cooling, the Mn-MOF crystals were collected, washed, and dried. The result, two advanced materials, each with unique properties: nanoparticles for activity, MOF for structure. The stage was set for the next step, combining them, science in action. Now for the real magic, combining the two materials into a nanocomposite. The scientists dispersed Mn-MOF powder in ethanol using an ultrasonicator, breaking up clumps for even mixing. They did the same with CuO nanoparticles in a separate beaker. Mixing both suspensions together, they stirred for hours, allowing CuO nanoparticles to settle into the pores and onto the surface of the Mn-MOF. The MOF's porous structure acted as a scaffold, creating a close connection between the two components. After filtering and washing, the final product, a dark powder of Mn-MOF/CuO nanocomposite, was dried in a vacuum oven. This hybrid material combined the strengths of both components. It was now ready to be turned into an electrode. A new catalyst was born, ready for testing. The future of clean energy was in their hands. The big question: does the new catalyst work? To test it, scientists made an electrode by mixing the nanocomposite with carbon black and naphthalene, then applying it to a glassy carbon disc. Once dried, the electrode was placed in an electrochemical cell with an alkaline solution. Using a 3-electrode setup, they measured the catalyst's performance. The results were impressive. The Mn-MOF/CuO catalyst showed a low overpotential, making the oxygen evolution reaction efficient. It outperformed electrodes made from just CuO or just Mn-MOF, proving the power of their combination. Durability was next. They ran the reaction for hours, and the catalyst maintained its high performance. This stability is crucial for real-world use. By designing and combining nanomaterials, the scientists created a catalyst that could help make clean hydrogen a reality. It's a leap forward for clean energy. Science is building a brighter, cleaner future. The journey doesn't end here. Imagine what comes next. Hello, science fans! Today, our planet faces a big challenge: how to power our lives without harming the environment. For decades, we've relied on fossil fuels, which release gases that trap heat and drive climate change. We need a cleaner energy source, and that's where green hydrogen comes in. Green hydrogen is a fuel that, when burned, produces only water, no carbon dioxide. To make it, we split water molecules using electricity from renewable sources like solar or wind. This process, called electrolysis, is clean and sustainable. But there's a catch: splitting water efficiently is tough, especially the part where oxygen is produced. The oxygen evolution reaction, or OER, is slow and energy hungry. To speed it up, we need a catalyst, a material that helps the reaction along. The best catalysts so far use rare, expensive metals like iridium and ruthenium. That's not practical for global energy needs. Scientists are searching for a catalyst that's both effective and affordable. Imagine powering the world with something as common as copper or manganese. The good news? Researchers may have found a promising new material. Let's dive into the science behind this breakthrough. The new material making waves is called Mn-MOF/CuO nanocomposite. Let's break that down. Nano means tiny, and composite means it's made of two materials working together. The first part, Mn-MOF, is a metal organic framework built from manganese, a cheap, abundant metal. MOFs are like atomic jungle gyms, full of pores and tunnels, giving them huge surface areas. The second part, CuO, is copper oxide, another affordable common material. On its own, CuO is a decent catalyst, but not great. By combining it with Mn-MOF, scientists hope to create a supercatalyst. They built the Mn-MOF structure, then embedded tiny copper oxide nanoparticles throughout it. The result? A unified material where both components work together to split water efficiently. This synergy is what makes the nanocomposite special. It's not just a mix, it's a carefully engineered team. The goal? A powerful, low-cost catalyst for green hydrogen. But did it work? Let's see how scientists checked their creation. To confirm they made the right material, scientists used powerful tools to examine its structure. X-ray diffraction, or XRD, reveals the internal crystal patterns like a fingerprint for materials. The XRD results showed peaks matching both Mn-MOF and CuO, proving both were present and intact. This confirmed the composite was successfully made. Next, they used FTIR spectroscopy to check the chemical bonds. FTIR measures how molecules vibrate when hit with infrared light, revealing the types of bonds inside. The spectrum confirmed the presence of manganese-oxygen and copper-oxygen bonds as well as the organic linkers. Together, these tests proved the nanocomposite's structure and composition. The material was real and ready for the next challenge. But what does it actually look like? Time to zoom in even closer. To see the material's shape, scientists turned to electron microscopes. Scanning electron microscopy, CM, revealed a crumpled, sheet-like structure like a tangled net. This rough texture means more surface area, which is crucial for catalytic reactions. Transmission electron microscopy, TEM, went deeper, showing tiny CuO nanoparticles scattered across the Mn-MOF sheets. These nanoparticles are just a few nanometers wide, perfectly distributed for maximum effect. To measure surface area, they used BET analysis, which calculates how much gas sticks to the material. The result? An astonishing 145.3 square meters per gram. Imagine a paperclip's weight covering half a tennis court. This huge surface area means more active sites for splitting water. The design worked. The nanocomposite was both porous and packed with catalytic power. With structure and surface confirmed, it was time for the real test: performance. Would it actually make oxygen efficiently? Let's find out. The next step? Put it to work in the lab. Here's what happened. Scientists tested the nanocomposite in the oxygen evolution reaction, or OER. They coated an electrode with the catalyst, applied voltage, and measured how much oxygen was produced, the key metric overpotential, the extra energy needed to drive the reaction. Lower overpotential means higher efficiency. The Mn-MOF/CuO nanocomposite needed just 281 millivolts to reach the benchmark current, better than either Mn-MOF or CuO alone. Even more impressive, it outperformed the expensive commercial catalyst, ruthenium oxide, which needed 303 millivolts. This shows the composite's synergy together. Manganese and copper work better than apart. The result? A low-cost, high-performance catalyst. This breakthrough could make green hydrogen production much more affordable. But efficiency isn't the only thing that matters. How does it stack up in other key areas? Let's look at the numbers. The race is on. Beyond overpotential, scientists measured the Tafel slope. A lower value means faster reaction speed. The nanocomposite scored just 61.3 millivolts per decade, beating both its components and the commercial standard. It also achieved higher current densities, meaning it can produce more oxygen at a given voltage. This is crucial for industrial-scale hydrogen production. The scorecard: lower overpotential, faster kinetics, higher current density, and massive surface area. And it's made from cheap, abundant materials. The Mn-MOF/CuO nanocomposite isn't just good, it's a true champion. It checks every box for a next-generation catalyst. But there's one more test: durability. Can it last in real-world conditions? Let's see how it holds up over time. The final challenge awaits. Will it endure? Efficiency is great, but a catalyst must also be tough. Scientists ran the nanocomposite for 50 hours straight in a demanding endurance test. They monitored its performance to see if it would degrade. The result? Almost no loss in activity. The catalyst stayed strong and stable. Many non-precious catalysts break down, but this one held up thanks to its clever design. Embedding CuO nanoparticles in the MOF framework protected them and kept the catalyst active. This durability means lower maintenance and longer lifespans for hydrogen production systems. Combine that with high efficiency and low cost, and you have a real contender for commercial use. The Mn-MOF/CuO nanocomposite isn't just a lab curiosity, it's ready for the real world. This could be a game changer for clean energy. Let's see what it means for the future. Stepping back, this discovery tackles a global challenge: clean, affordable energy. Green hydrogen is a powerful solution, but it needed a better catalyst. By engineering a nanocomposite from manganese and copper, scientists created a material that's efficient, durable, and cheap. Careful tests confirmed its structure, performance, and stability. It beat the old, expensive standard and proved that smart material design can solve big problems. Using abundant elements slashes costs and opens the door to widespread adoption. This isn't just a small step, it's a leap toward making hydrogen fuel accessible for everyone. The future of clean energy just got a lot brighter. Science is turning possibility into reality, and the journey is just beginning. The Mn-MOF/CuO story is more than a science experiment. It's a story of hope and progress. It shows that creativity and curiosity can solve even the toughest challenges. Climate change is daunting, but breakthroughs like this are happening every day in labs worldwide. The next step, scaling up this material for real-world use. Other scientists will build on this work, making it even better. Progress comes from collaboration and relentless curiosity. Stay curious, ask questions, and support science. The future is built by those who explore and innovate. Clean energy breakthroughs start with understanding and imagination. Let's keep learning and pushing boundaries. Together we can shape a sustainable future. The world is counting on it. Hey, welcome back to the channel. Today I'm wrapping up a fascinating research journey into the future of clean hydrogen production. We're talking about the Mn-MOF/CuO nanocomposite. A mouthful, I know. But trust me, it's a big deal for sustainable energy, so let's break it down. Electrolytic water splitting is getting a ton of attention as a clean energy source. Basically, it's about splitting water into hydrogen and oxygen. The tricky part, the oxygen evolution reaction, or OER, which is where we need really good electrocatalysts to make things efficient. That's where this study steps in. The researchers mixed copper oxide nanoparticles with manganese-based metal organic frameworks, that's the Mn-MOF/CuO, using a simple, cost-effective hydrothermal method. They slapped that composite onto a conductive surface, then put it through its paces. Here's what they found. The onset potential was just 1.43 volts. It only took 247 millivolts of overpotential to hit a current density of 10 milliamps per square centimeter. And get this, the Tafel slope was just 48 millivolts per decade, which means electrons were moving fast and efficiently. What makes it work so well? Three things. First, the catalyst has a huge surface area, which gives reactions more space to happen. Second, it's super permeable, so the reactants get where they need to go. And third, there's a cool synergy between the CuO nanoparticles and the MOF framework, speeding things up even more. Altogether, these features mean better, faster reactions and a catalyst that stays strong over time. Exactly what we want for real-world hydrogen production. But it's not just about lab results. This study is a step toward designing greener, more effective nanomaterials for energy. If we nail this kind of catalyst, clean hydrogen could actually become something we use every day. Not just a science experiment. Now, a quick shout out to the team that made this happen. Dr. Bushra Shabbir led the charge on visualization. Huge thanks to the research team for their writing, review, and editing work. Dr. Sumaira Manzoor and Dr. Mohammed Fahad Ehsan also helped with visualization, and Professor Dr. Mohammed Naeem Ashik provided top-notch supervision. No conflicts of interest have been declared, and if you want the data, just ask. Big support came from universities in Pakistan and Saudi Arabia. It's awesome to see this kind of international teamwork pushing science forward. So, what's the takeaway? Every step forward with materials like Mn-MOF/CuO gets us closer to making clean hydrogen a reality. Thanks for watching. Don't forget to like, share, and subscribe for more science that matters. For Science Salah Lotfy channel, bringing the world's research straight to your screen. As we reach the end of today's episode on the promising Mn-MOF/CuO nanocomposite and its potential in clean hydrogen production, Professor Dr. Salah Lotfy would like to extend his deepest gratitude to all the brilliant minds who contributed to this outstanding research. At the heart of this study is Dr. Bushra Shabbir from the Institute of Chemical Sciences, Bahauddin Zakaria University in Multan, Pakistan. Her vision and scientific leadership laid the foundation for this innovative work. Also deserving recognition are a group of dedicated researchers and collaborators from across the globe. Dr. Nidal Drisi, a PhD researcher from King Khalid University in Aba, Saudi Arabia. Dr. Karam Jabber, PhD candidate at the American University of the Middle East in Kuwait. Dr. Abdelaziz Gassoumi, PhD researcher affiliated with both King Khalid University, Saudi Arabia, and the University of Tunis El Manar in Tunisia. Dr. F. Al-Harbi, PhD candidate from Princess Noura bint Abdulrahman University in Riyadh, Saudi Arabia. Dr. Sumaira Manzoor, from Bahauddin Zakaria University, Pakistan, whose contributions in visualization were pivotal. Dr. Mohammed Fahim Ashik, another talented PhD researcher from the same university. Dr. H.A. Al-Baraihi, PhD researcher from Princess Noura bint Abdulrahman University, Saudi Arabia. In addition, this study benefited greatly from the expertise of Assistant Professor Dr. Mohammed Fahad Ehsan from Northeastern University in Boston, USA, and was overseen with care and academic leadership by Professor Dr. Muhammad Naeem Ashiq, supervisor at Bahauddin Zakaria University, Pakistan. To all of you, thank you for your remarkable work. Your collaboration across disciplines and nations is a model of what science can achieve when driven by shared purpose. And finally, to our valued viewers, thank you for spending time with us on For Science Salah Lotfy channel. What do you think of this innovative approach to green hydrogen? We invite you to share your thoughts and questions in the comments section below. Let's keep the conversation going. If you appreciated today's episode, don't forget to like, share, and subscribe. Your support encourages us to continue spotlighting global research that matters. For Science Salah Lotfy channel, science that connects minds across borders.